happens if I get a dependent source? That means I got a DC. Okay? So what you want to pay attention to here is that I'm still interested in trying to connect the voltage of the capacitor and the current of the capacitor. Now, if I have a DC like this, then I got to remember that DC has to either be written in terms of IC or VL. Since we're short on time, probably the most important thing here is that to really sort of like intuitively go after it and then derive the equation to make sure that we get at least that much there. Okay? So, what do you expect of the capacitor? What do you expect the capacitor to behave like at t equal to infinity? It should be an open. Right? And one of the things here, it should be an open, of course, but it should go to 0. Because think about it, the only active source that's constant is being what? Taken out of the circuit. And because this is taken out of the circuit, this will give it a burst for a brief amount. But then that Ix, because nothing is resupplying this thing, goes to 0. So immediately what we're seeing here in this circuit here is that we're seeing that at VC t equal to infinity, it should go exactly to 0. So that means when I derive my equation, my right side of the differential equation should be exponential and therefore should be 0 when t goes to infinity. So this implies here that the right side of the first order equation must only depend on e to what? E to the minus 5t. By the way, there's going to be another term. I think there will be 2 terms. It should only depend on negative exponentials. Right? It can only depend on negative exponentials. So let's do it. So what we want to do here is that we want to derive the first order equation. So as I said before, our goal here is that we want to do what? We want to write an equation where I try to connect that voltage to the current. And what you're seeing here is that the voltage source here, right, this is gone. So it seems like the only reasonable way to look at getting the voltage across the capacitor, what, is to go all the way around here. Right? Because the voltage here has to be the same as the voltage there. And then, in order to rewrite this in terms of the current of the capacitor, I got to look at KCL as one of the nodes. Either down here or down there. It doesn't matter. Okay? So let's do that. So now, we're at t equal to 0 plus. What's my circuit? Looks like this. Right, so we know this is 136. We're interested in solving for what? DC. We can see here that this guy's 2ix. We see that this guy's 12. And we know that ix is in this direction right here. So the only way I can get the voltage is to do a KVL loop. So I'm going to apply a KVL loop. So if I apply a KVL loop around the outside, Let me turn this off now. I can pick any direction that I want. I'm going to make this my positive direction. Note that this immediately defines that to be positive and negative. So I'm going to go what? I'm going to go this direction. So I'm going to get what? The voltage across the 12 ohm resistor. Then I come here, I get the negative 8e to the minus 5t. I come here, I hit the positive VC, I get 0. So now I got VC, so my job is to write down this DC in terms of what? IC. So we could say that the job here has to be rewrite IX in terms of IC. So if I do that, I'm going to look at this node right here. And if I look at this node, let's call this node, I don't know, D. You can see here that the current is IC right there. So now I apply my dependent condition, I guess. My dependent condition is then going to be, I get what? I get this current coming in, this current coming in, that current coming out. So I'm going to go, the current in will be IX plus 2IX equals IC. So now I replace this guy. So then I see here that IX is equal to 1/3 IC. So now I'm going to take this, I'm going to plug it right into here. And if I do that, I'm going to get what? 12 times 1/3 IC plus VC equals, then I'm going to take this to the other side. I get 8e to the minus 5t. Now let's clean this up a little bit. How am I going to clean this up? I'm going to say that IC, like this here, so let's do this here. So this is 36 here. So if I look at this guy here, this is going to give me 4. Okay, so this is going to give me 4 times 1/36 dV dt plus Vc equals 8e to the minus 5t. So what do I got to do? I got to isolate this guy. Right? If I isolate this guy, that means I got to multiply everything by 9. Right? So I got 1/9, so I'm going to get dV dt plus 9 Vc equals 72 e to the minus 5t. And there's my equation. Now, does this equation make physical sense? Well, let's check it. So we want to do a quick check. So we want to check the equation. We know that at Vc equal to infinity, this guy should be equal to 0. Right? As we discussed already. No sources, right? That's going to die off exponentially. So what you're seeing here is that it's also equal to a constant. So if I look at that equation right here, we're going to get what? d of 0 dt plus 9v. I shouldn't have done that. I should have called this a constant. How about if I call it Vc infinity? So we're a little bit more clear. So I'm going to write dVc at infinity dt plus 9Vc at infinity equals 72 times e to the minus infinity, which is, of course, 0. That goes to 0. So this immediately tells me that Vc at infinity should be 0, which is exactly what we expected. Right? So I'm checking as I go through this here. So now, let's go write down the solution. So I'm at step 2. So what I'm going to write then is I'm going to look at my equation, and And I'm going to write my solution here. So what I'm going to see here is that I get Vc of t has a natural response. What's the natural response? Well, it has to be that guy right there. I pull off the tau, so it's got to be e to the minus 9t, right? That's the natural. Plus the forced response, and you can see that it has to be e to the minus 5t, so I'm just going to write this as be to the minus 5t. So my job now is that I got to do what? I have to solve for b by subbing into first order equation. So let's do that. So it's only the forced response that I got to plug it in. I could plug them all in, but we're going to do the forced response. So if I do that, I'm going to get what? Vf dt plus 9Vf equals 72 e to the minus 5t. This tells me here that I'm going to set Vf as b e to the minus 5t. Okay? So if I plug this in here, you can see that I'm going to get what? This equation then tells me that I'm going to get minus 5b e to the minus 5t plus 9 b e to the minus 5t equals 72 e to the minus 5t. And right away, we can see here that these guys all cancel out. So you can see here that I have what? 9 minus 5 gives me 4. 4 divided into 72. So this tells me here that b has to be 72 over 4, which is what? 36, is that 18? Okay, so then this is 18 volts here for b. So now I got this here. So then what I'm left with now is I'm going to substitute that into my equation here. So now the general response is Vc of t equals a e to the minus 9t plus 18 e to the minus 5t. So we did really 3 things. We wrote down the general response, we solved for the forcing constants, the b's, and then we wrote down the general response equation. So now what I got to do here is that I got to do what? I have to determine initial condition. So then that means I got to go back to my circuit here. So my circuit looks like this. So at t equal to 0 minus, remember Vc is in open. Right? You got to remember that. So if I write this out here, my circuit then looks like what? So I got a 12. I have a current source. I know this is 2Ix, this is Ix, and this is the 12 ohm. And then I have no voltage source, right? There's no exponential source, but then I have an open here. Okay, if I have an open there, then I have my switch here, which is the 3, and then I have a source here that reads 38.5 volts, and this guy here is a 3 ohm. And what we know here is that we're interested in this guy right here, Vc of 0 minus. Yes? Not at 0 minus. So now I just got to solve for the voltage of this guy. There's lots of ways that we can do this here, but what's probably the fastest? You know what? The hell with that. Let's just write it down. Right? We don't got that much time. So we'll say here is that you solve for VC 0 minus, and what we get here, if you get that number here, I end up getting positive 22 volts. And at least the sign looks good, right? That voltage here has to be the voltage across that 12 ohm resistor, because they're all in parallel. Yeah, these three are in parallel, at least. So then, what I'm going to do here is that then I'm going to sub to determine A. So then if I take my equation, I'm going to write VC of 0 minus is 22. That equals A e to the minus 9t plus, no, it's got to be 0, plus 18 equals to e to the 0. And you can see here that that 18, when I bring it to the other side, is going to give me 4. So this tells me here that A is equal to 4. Okay, so I got my initial condition. I apply it to get my A, and I am out of space. So I'll walk all the way over here, and I see that VC of t is then 18e to the minus 5t plus 4e to the minus 9t volts.